Hello. Um, Today is lesson 2.5 about angle relationships. We're talking about special pairs of angles, and that was something that we discussed at the beginning of the year. Please don't forget to write this, include the date, and write that. This is optional. Before we get started, we need to talk about a conditional statement. It is an if-then statement. After the if is the hypotenuse, after the then is the conclusion. The converse of a conditional statement is when the hypothesis and the conclusion are switched. So let's do an example. If you are a math teacher, you teach math. All right, so underline the hypothesis once and then the conclusion twice. Class, you can always pause at any time, and I think you should, just to try things on your own. Before I do it, it'll give you more confidence. And if you get it wrong, no one will know. Then you just erase it. Right. So is that a true statement? Well, if you're a math teacher, yes, you teach math. Now, that doesn't mean you can't teach something else, but do you at least teach math? The answer would be yes. So a math teacher, you can still teach computer science or PE, but do you teach math? Yes. Okay. So what do you think is the converse of that? So pause and write that down. And is it true or false? Right. So said, we switch the if and then. So if you teach math, then you are a math teacher. Can you come up with a counterexample to disprove that? So think about that. And you probably already have an answer. So this is my answer. I knew a foods teacher, and she taught math. She taught one section of algebra. I know business teachers that taught math. I know third grade teachers that teach math. I bet some of you students, you teach math. Are you a math teacher? Not yet. All right, linear pair theorem. The book calls them conjectures, but we are going to prove them. So it's going to be a theorem. So if two angles form a linear pair, then the angles, I think I'm going to change that. I changed it. Then the angles, well, you could say it two different ways. Then the angles are supplementary. And the angles add up to 180 degrees. So I want this specifically, but we could do also supplementary. All right, so we are saying a linear pair, if you remember that, it's two adjacent angles that form a line. So this plus that equals this. Okay. Now, I don't know if we have one definition. This book may not have done it, but I'll talk about it as we do the proof. Okay. So a geometric proof has a couple different parts. It has a given, angle DXL and angle LXL are linear pair. And this actually comes from the hypothesis if two angles form a linear pair. And we did. We said the two angles and they're a linear pair. And then guess what the conclusion is? Well, you're right, is what you prove. So that's where it comes from. So if you have a statement that you want to prove, the if part's the given, and then the prove is your conclusion. Okay. Geometric proofs also have a diagram. I'm going to say 99%. There's a few that don't, but they're usually very basic or extremely complicated. And then you have the two column proofs. So again, the given, the proof, the diagram, and then the statement and reason. The first step, the first line statement, is a given. And you're going to say, Miss Mendoza, is it always? Now, the moment you say always, this is my funky and. The answer is no. There are times when you don't. I'm going to use are, a linear pair, just because I write big. Given. Usually the given is the first line. Okay. Now I know, what do I have for that? So you have to think of, what do we know? What do we know about this? Well, I do remember there's a postulant, I believe you learned. This plus that. Okay, oops, forget the M, equals the measure of dxo. Do you remember that? This plus that equals the whole thing. Do you remember what it was called? Okay. Angle addition postulate. Now this is a definition that I don't think we did in class. Angle dxo equals 180 degrees. And this is definition of a straight angle. Now your book actually probably uses something called a ruler postulate, or some of them do, but we didn't do a ruler postulate. But I do know that most of you know that a straight angle, flat line, the angle, right, is 180. Here. Okay. Now, let's look. Always look at your lines. So you're like, okay, what do I see? Well, I know this equals that. Oh, look at that. This is the same. And that equals this over here. So if two quantities equals congruent quantities, which they do, then they must be equal. So this must be equal to that. Do you remember the reason for that? DXL plus LXO equals 180. Do you remember? Do you have your Snoopy paper looking at it on your computer? All right, it is a transitive. Transitive property of equality. No, I would not use substitution for that. All right. Oh, are we done? Are we done? Yes. So if you hit the last line, you stop. Now, could I have proved them supplementary? I could do another line. So I can prove that as well. All right. Are we okay? All right, moving along. Vertical angle theorem. All right, do you remember what vertical angles are? Two angles form from intersecting lines that are non-adjacent. Okay. So you actually have two pair. I'm just going to pick these two pair. So if two angles are vertical, then, I know you know this, we had long debates about this, then they are congruent. Okay. Are equal. All right. So we see our hypothesis. So that should be, because of course we're going to prove it. I said it's going to be a theorem. So that, and then here, oops, come on. This is our conclusion. So that's what we're going to prove. So I need two angles that are vertical. So, all right. So sometimes in proofs, instead of using all the letters, they actually write numbers, and we do this to make our lives easier. This is easier. So I have two angles that are vertical. So we see this angle over here and this other angle here, and we're trying to prove that they are congruent. Okay. So you can't use a theorem until you prove the theorem. But if you've proved it, you can use it for another proof. Okay. So what's a given, right? That's always, this is going to be our first statement. And, oh, I forgot the word R. Our vertical angles are vertical angles. Okay. Reason, That's right. And I want you to say it out loud. I know no one's there. Say it in your head. It'll help you when you have to do proofs on your own, if you try to say it before I get there. All right. So what do I know? So let's look. So I like to look at my diagram. So what do I know? Well, similar to the last one, I know that this and this equals 180. I also know this and this equals 180. Okay, so I'll stop there and write that down. So do you see, if I don't know it all, that's fine. Just stop and write down what you know. Okay, so that equals 180. And what's the reason for that? Linear pair postulate. Okay. And we also said angle 2 plus angle 3 equals 180. Oh, okay. Got that. Oh, linear pair postulate. Okay, so I guess I could have kept that on the same line. So I didn't have to, since it was the same reason. But I'm just going to write it again. No big deal. So what do we notice? This equals 180. Oh, but 180 is also there, and it equals this. So then we know those two things. Measurement angle 1 plus the measurement of angle 2 equals the measurement of 2 plus the measurement of angle 2. Okay. Dan, again, transitive property of equality. All right, so, and then we're like, okay, so we're close, right? We're really, really close. The only thing that's different is those 2's. I need to get them out of there. Oh, but aren't they equal to each other? You know, like, guess there, Ms. Mendoza. Do you remember that property? Reflexive property of equality. And you're like, why do I need it? Because I need it here. I need to say that this angle here, right in the middle, this angle is equal to itself. Right? You're like, okay, because why? Because now I can subtract measurement angle 2 from line 4, right? On both sides. Oops, angle 3. And what's the reason? The reason is subtraction, property of equality. You're like, wow, yep, use subtraction. Last line, you're like, what? I didn't say it was congruent. You're like, we have to do that? Well, we have to prove exactly what it is, and we didn't do it. So you're like, why? Definition of congruent. If it's the measurements are equal, it is congruent. All right, so let's go back to converses. What is the converse of vertical angle theorem? So 2 angles are vertical, then they're congruent. So if angles are congruent, then they are vertical. Right. Is that true? Well, no. I have 2 angles like this here. They're adjacent, they're not vertical, and that is false. Okay. So let's do some practice problems. Now we have 2 theorems, linear pair and vertical angles. And how you go about them is really up to you. I'm going to take one approach, but you may do it a different way, and that's fine. All right, I always like to do vertical angles. So I say, okay, these 2 are vertical, so this is 57. Now these 2 over here, they're not vertical, they're adjacent, right? So they add up to 180. So I'm going to subtract 180 minus 57 is 1 123, right? We'll check my work. Yes, 123. So you can subtract that, but I also know that's vertical. Yeah. Doesn't that turn out nice? Pretty? 4 angles with 2 different measurements. Very good. All right. Find the value of each variable. Well, I don't have to find this, but I'm going to say this anyway. That is 90. These two are 90. So this is, and so you may want to pause because you may do it in a different order than I, and that's fine. Okay. So these two also equal 90, right? So this is 90, this is going to be 90. So I'm going to do 90 minus 38, which is, oh, look at that. It's 52. I wonder if that's a theorem. And why that's true. Okay. Now, what about the C? Well, C is different. That's way over here. This is 180, right? I like to write down things I know. So if you're stuck, just write stuff you know. Oh, okay. Well, that whole thing's 180. If I subtract 52, I will get that. So this is 128 degrees. Excellent. Oh, okay. This one's a little bit more tricky. Find the measure of each angle. Oh, so it's not asking for X or Y. I may need it, but they're actually asking for the angle. Each angle. Okay. So let me look here. Well, I know these are congruent, but they're different variables, so that's not going to help me. Same thing for these two vertical angles. Well, but I know these two are also equal. Not going to help me. But what else do I know? Oh, I know these two are 180. And since they both have X, that's going to help me. Right? So again, it's really understanding what you see. And when you're stuck, just ask yourself, what do I see? Oh, I see these angles. What kind of angles? Oh, I see supplementary angles. I see linear pair. I see vertical angles. And then that will help you. All right, so 40? Nope, X is 40. I have to figure out how much that angle is. Now, there's several different ways to get Y. Over here, I'm going to find the angle. And I believe 40 plus 15 is 55 degrees. So I know this is 55 degrees. Now you can make it these two equal 180. That's fine. But I think this is a pretty simple equation. Something I don't think I'm going to make a huge mistake on. All right. Oh, you know what? I don't even think I needed to find Y. It just asked me for the angles. My bad. I know someone probably was just like, Miss Mendoza, did you have to? No, I just wasn't thinking. So used to finding variables. Okay, so there you are. Now, in your notes, there's sometimes I'm going to say in the videos, class, do this problem. I'm not going to do it. I want you to try it on your own. Put it in your notes still. And that's one of the things I will look at to see if you did it. Doesn't have to be right, but I want you to try it. You can check with the people, your peers, the next day when we go over homework. You can also go over your notes and see what they got and compare your answers. All right. Don't forget to answer the EQ. All right. Until the next time, stay safe. Ciao.